I thought it might be helpful if I worked out balancing a redox equation problem. And so you can just focus on it, stop it when you want, review when you want. So I picked this one because I think it'll be representative of what you'll see on your test. So you always want to start by assigning oxidation numbers to every single atom. And I always start by assigning oxygen a -2. Then I do my math below the atoms. So there are seven oxygen in Cr2O7. So oxygen contributes -14. All of the oxidation numbers need to add up to be the charge on the substance. So dichromate has a charge of -2, so the chromium element collectively has to contribute +12. Okay, +12 minus, that's 14 squished in there, is -2. But since there are 2 chromium, that means that each chromium is going to have an oxidation number of +6. So make sure that the numbers you write on the top are for one single atom. So moving on to nitrous acid, oxygen contributes -4. I know that hydrogen is +1 99% of the time. And then I know that these 3 oxidation numbers, when they add up, that -2 is for the oxygen. That overall, this compound is neutral. When they add up, they need to add up to be 0, which means that nitrogen in this compound is +3. Okie doke. And then this one's easy. Ions on their own simply have an oxidation number equal to their charge. And then figuring out the nitrate ion. The oxidation numbers have to add up to be the charge, for which for nitrate is -1. So nitrogen in this case must be +5. All right, so I have the oxidation numbers for every single element on both sides of the reaction, and now I'm going to compare these oxidation numbers to decide what has been oxidized and what's been reduced. Chromium has changed its oxidation state from +6 to +3, meaning that it has gained 3 electrons. Remember, electrons have a charge of -1. And so Leo says GR, gain electrons reduced. So my reduction half reaction involves anything that it has a chromium on it, right? So this is my reduction half reaction, unbalanced at this point, just right. So I need to figure out what's been oxidized now. So looking at all the other oxidation numbers, I see that nitrogen has changed from +3 to +5, which means that it has lost 2 electrons. Okay, lose electrons oxidized. So my oxidation half reaction is anything that has nitrogen in it. Alrighty, so there are the half reactions, skeleton half reactions. Let's go ahead and go through the steps to balance them. Step number 1 is to balance all atoms except for oxygen and hydrogen, because those are balanced in a special way, right? So let's see. Only thing I have to look at in the oxidation half reaction is nitrogen, and it's already balanced. I see in the reduction half reaction that I need to balance chromium. So I'm going to put a coefficient of 2 on the product side. All right, so the next, after you balance the non-oxygen, non-hydrogen atoms, move on to oxygen. And you will balance oxygen by adding H2O molecules to the appropriate side of the half reaction. So you can see on the reactant side, I have 2 oxygen. On the product side, I have 3. So I need to add 1 water molecule to the reactant side, which will give me 3 oxygen atoms on both sides. For the reduction half reaction, I have 7 oxygen on the reactant side, none on the product side. So I've got to add 7 water molecules to the product side just to balance oxygen. Right, when you are done balancing oxygen, and you may want to write down these steps, y'all, okay? When you are done balancing oxygen, then you move to hydrogen. And be careful because you might have more than one source of hydrogen. So in the oxidation half reaction, I have 1 hydrogen from the HNO2 and another 2 from water. So I have 3 hydrogen on the reactant side. So I need to add a 3 hydrogen ion on the product side. And then for the reduction half reaction, I've created, I'm going to change my pen on me, sorry. I have created 14 hydrogen atoms on the product side, so I need to add 14 hydrogen ions on the reactant side. So now all of the atoms are balanced, and at this point you are ready to balance the charge. The overall charge has to be the same on both sides of the reaction. And so that's the tricky part. That's where all the mistakes are made. So very carefully, remember that charges are shown in the upper right portion of every substance. So if there's nothing up there, there's no charge. So the reactant side of our oxidation half reaction has 0 charge. Looking at the product side of the oxidation half reaction, NO3, did I forget? I forgot to carry a charge down. See, I caught myself. This has a negative charge. Yeah, nitrate. And I just left it off when I copied it over. And then, of course, each of the hydrogen ions has a charge of +1. So my total charge on the product side is -1 from the nitrate ion, +3 from the hydrogen ion. So my total charge on the product side is +2. Remember, my total charge on the reactant side was 0. So in order to get the charges on both sides of the arrow to match, I need to add 2 electrons to the product side of the oxidation half reaction. So let's go through that for the reduction half reaction. Okay, the total charge in the reduction half reaction is -2 from the dichromate, +14 from the hydrogen ions. So the total charge is +12 on the reactant side. On the product side, the total charge is 2 times +3, or +6. So I need to add 6 electrons on the reactant side, which will give me a net charge of +6 on both sides now. So just in case this helps anybody to kind of check yourself, because it's so easy to make mistakes, the electrons will always be added on the product side if it's oxidation, and the electrons will always be added on the reactant side if it's reduction. Okay, reduction means reactant side electrons. Oxidation means product side electrons. Alrighty, now each half reaction is completely, totally balanced, but I am not done. I need to combine the 2 reactions, half reactions, and before I do that, I need to make sure the electrons I've added are the same, so that when I add these reactions together, the electrons will cancel out. So I can get these to be the same by multiplying the oxidation half reaction by 3. So I'm going to go ahead and write that out here so you can see what it looks like. So you have to make sure that everything gets multiplied by 3, not just the electrons. So now I have 3 HNO2 plus 3 water gives 3 NO. Yeah, it's acting up on me, sorry. 3NO3 plus 9 hydrogen ion plus 6 electron. Okay, so now you can see I have 6 electron in both half reactions. Now I can add them together. So anytime you add reactions together, it's real easy. You just add all of the reactants from all the reactions you're adding up together. So I'm literally just rewriting. Right, so those are all of the reactants from both half reactions. So now I'm going to list all the products from both. Oopsie daisy, sorry. All right, the final thing that you need to do is cross out anything that is the same on both sides of the arrow. And it has to be exactly the same, okay? Exactly the same element or molecule, exactly the same charge, identical, all right? So the electrons should always cancel out. That's the whole purpose of doing this half reaction. And does anything else cancel out? Well, this is where it gets a little tricky. If you have water on both sides, or if you have hydrogen ion on both sides, as we do here, then it's like a simple math equation where you're trying to combine like terms. So let's look at the water first. I have 3 water on one side, 7 on the other side. So if that were a math equation, what would you do? You would subtract 3 water molecules from both sides, right? And it would cancel out on the lesser side. And you would end up with 4 water molecules on the product side. Same with the hydrogen ion. Let's subtract 9 hydrogen ion from both sides. And it goes away there. And 14 minus 9 is 5 hydrogen ions left. All right, so the final answer is what is left, and I'm out of room. So you would just rewrite, okay, the 3 nitrous acid plus 1 dichromate ion plus 5 hydrogen ions gives 3 nitrate ions plus 2 chromium 3 ions plus 4 water molecules. And that is your answer. I hope that's helpful.